Hi, welcome to the next session and an intro to data analysis. In this session, we'll be learning how to tidy data, that is, preparing messy data for analysis. By the end of this lesson, you should be able to convert data to tidy format, and if you don't know what tidy format is right now, that's okay, we'll be learning about it in this session. Let's take a walk down memory lane of where we've come so far in this journey of data analysis. We started with data visualization. We learned how to do data transformation, doing things like select, filter, arrange, mutate, and summarize, as well as to use group by. We used those skills, and we headed back into data visualization, picking up some theory along the way, and some understanding of how to use those data transformations to make our graphs even more powerful and to show more things. We learned how to show the patterns and relationships between variables, and what types of patterns we're looking for. From there, we learned how to do exploratory data analysis, an iterative process where we ask questions about the data. We use transformations and visualizations to understand those questions, and along the way, generate new questions iteratively. Up till now, though, our data has always been in a pretty nice format to work with. In the real world, though, data is messy, so we need some tooling to help us to be able to turn our data into tidy data. To be doing that, we'll be using the tidyr package, which is part of the tidyverse package by Hadley Wickham and friends. And again, to recap, exploratory data analysis uses visualization and transformation to answer questions that we ask, and along the way it generates new questions and allows us to refine our old questions or new questions and just continue this process until we understand the data set and the relationships between variables. Now let's move into tidying messy data. Leo Tolstoy says that happy families are all alike. Every unhappy family is unhappy in its own way, and Hadley Wickham quips off of that, tidy data sets are all alike, but every messy data set is messy in its own way. To help us understand what tidy data looks like, I think it's important to understand some of the formats we often see data in. So here's one format, a crosstabs, which can be quite useful. What if I were to ask you, what are the variables here? Think about that for a moment. What are the variables that are being looked at or that one is trying to understand from this data set? What if I were to say to you, there are 3 variables? What are they? If you haven't figured it out, the 3 variables are course, professor, and rating. The way this data is set up is really quite nice for querying, but it kind of hides away what the variables are that are being studied. We could have also shown the data like this, where we put the professors across the top and put the courses along the left-hand side. Now, what if I were to ask you what are the variables in this tidy data set? And it should be much quicker. The names of the columns are all there, and they tell you exactly what types of variables we're looking at. And you could even clean up the redundancy in some of the variables, as I've done here, by removing them. Not necessarily for the computer, but if you were trying to display this table for publication, that is. So which one do you think is tidy and which one do you think is untidy? This left one here is optimized to look up ratings and professors for courses. This right-hand one is optimized for thinking scientifically, for thinking about what are the variables, what are the observations, what are the measures. So they're each useful for different tasks. And if I were to tell you that the rules of tidy data is that every variable must be in its own column and every observation should be in its own row, the last rule is every value must have its own cell. That's actually redundant. If you do the first 2, every value will have its own cell. So these are the rules of tidy data. The first 2 are really all you have to remember. Every variable has its own column, and every observation has its own row. So which one of these is tidy and which one is untidy? The cross-tabular is untidy, whereas the one on the right is tidy. The one on the right, every single one of the variables has its own column. So which one is better? And I think the answer really depends on what you're trying to do. If you're trying to show or communicate the results to yourself or other people, the untidy crosstabs may be really quite useful. But if you're trying to understand scientifically what's going on and you're trying to feed the information to dplyr or to ggplot2 and you really want to understand what are the variables that I'm looking at and trying to understand, then the tidy format is better. And I do want to point out that oftentimes Hadley doesn't use these terms himself. He says they're not precise enough. But oftentimes an untidy data set is known as wide data and tidy data is known as tall data. So I wanted to make that distinction. Oftentimes in analysis you'll hear people talking about wide and tall, and they're very similar to wide is very similar to untidy and tall is very similar to tidy. And the ggplot2 package and dplyr package makes the assumption that your data is indeed tidy. But oftentimes your data comes to you in messy ways, we'll say. So what are you going to do about that when data comes to you messy? You need the tidyr package to tidy it up, make it look like the younger John Lennon, and now you can feed it into dplyr and ggplot2. So how do we turn the untidy data into tidy data? And if you kind of look at these two data sets, you could kind of think about it like this. So you have some columns that are quasi-tidy already, in a sense that they are variables in their own column. And then you've got things that are spread out, and what you would need to do is figure out which one of those is which. So which columns are quasi-tidy already, and which columns need to be spread out. So if we want to find the ones that are quasi-tidy already, it's the professor column. That is a variable in its own column. And what we need to do is to go ahead and grab that. We need to repeat it for the number of columns that are untidy. There are 2 columns that are untidy. That's the course 1 rating and course 2 rating. So we need to repeat that variable, or that particular column 2 times and stack it on top of each other, right? Then we need to take the column headers for the untidy columns, repeat each of those for the number of rows underneath of them. There we repeated course 1 twice, or 3 times. And then we do the same with course 2, repeat it 3 times, put it next to each professor. Then we grab the ratings, stack them on top of each other, and now we have a tidy data set. Of course, you need proper column headers, but it's tidied. But this is kind of a pain. So there's a much better way to do this using the tidyr package, and that's the gather function. And it's fairly simple. You give it a key to rename the variables, the column headers that you're going to stack. You also give the values from the cells. They're going to be stacked on top of each other. What will you call that? And then you need to go ahead and tell it the variables that you want to stack. So in this case, we want to take the course 1 rating and the course 2 rating. These are the variables that are untidy. And so we would say, okay, the column headers, really, we're talking about courses here. It's course 1 and course 2. So the key is course, right? And then we want to figure out, well, what are the cells dealing with? Well, in this case, the cells are talking about ratings. So we'd want to call that ratings. And then we need to tell it what columns we want to stack. So in this case, we want to stack columns 2 and 3, course 1 rating and course 2 rating, right? So it's kind of nice to show it in PowerPoint, but I think it's much more meaningful to show it in code. So let's go ahead and code that up a bit. Okay, we have opened up the 08 reshaping data.r script. The first thing we'll do is go ahead and load our dependencies here. And the next task it has us doing is to create an object called professor or profdat. So you're going to have to assign something to profdat. And what they want us to do is to create a data frame that looks like this. It's an untidy data frame. So go ahead and pause the video and do that now. So you should have finished up by now. Go ahead and assign that, and we'll look at it. Let's see if it looks like a table. Yeah, it does. Okay, the next step it wants us to do is to learn how to tidy up this data. So what we're going to do is use the gather function, and it works like everything else we've been using where we pipe it forward. We take profdat, we pipe it into gather. And what do we want to gather up? We want to gather up columns that are untidy. Right here are the 2 columns. And the first thing we do is name those. So what are these columns all about? Well, they're about courses, so we're going to call it course. Next, we got to figure out, well, what are the cells we're going to be grabbing? These cells and these cells. And what are they about? They're about ratings, so we call it rating. And then lastly, we tell it what columns we're going to stack or tidy up on top of each other. And it's these 2 columns here. So that's the third argument, right? We go ahead and we run that. And now we're in tidy format. So every single variable has its own column. Every observation has its own row, right? A couple cool things you can do with this gather. It says here you can select negatively or with colons that may save typing. So for instance, we could have said, you know what, originally the only variable that is already kind of tidy that we don't want to stack is professor. So we can just say minus professor. If you have more than one of those, you could wrap it with a C. And that works just the exact same way. We could have also have used the colon operator, where we say from this column to this column, go ahead and stack. And that works as well. You could also throw in extra columns that aren't from A to Q or something along those lines. You could do like A through C and then M by using like a comma, M. In this case, I obviously don't have a column named M, so I can't do that, but go ahead and see that it works as well. Okay. So negative indexing and the colons can be nice ways to save a little bit of time. I'm going to put those back into the script so we have them. All right, now we're going to take a look at the buffalo snow, the untidy buffalo snow. And you can see it's in wide format. We see months across the top here. And we can see a season column. So what we have here are months for column headers, right? So this is a crosstab. We actually have untidy data. So how would we tidy this? So we have some steps here. I would encourage you to pause the video now and try working out some of these steps on your own, and then we'll work through them together, okay? So the first thing that we need to do is grab our data. We need to go ahead and pipe it forward. And I know right off the bat we need to gather this data because we need to type it, right? And I know that these are all months, so I probably want to call this something like month, right? And then I know that the values in the cells are snow, so I want to call it something like snow, right? And what columns do I want to grab? Well, I could say all of them. I could type them all out, put commas in between. That's kind of annoying. I could also do July through June, and that's ready. So I'm going to go ahead and do that so you can see what happens here. Another thing I could have done, which is even less typing in this case, is to say minus season, or maybe it's about equal amount of typing, and we get the same output. Doesn't matter. Okay. Next, it says, hey, snow is a character when it should be numeric. Why is it a character? And we have opened up the data set by saying question mark Buffalo snow, and it tells us that the data set contains historical records. Columns are in character because of the T cell values. So there are T's in some of these cells you see up here. So the data is assumed to be character because it's mixed, right? And that's the least restrictive. So to give you an example of that, we take C. Let's say we have, so we're making a vector, that is. So let's say we put 12 in there and then I put the letter T. Well, it turned the 12 into a character as well. So if we say is numeric around that, it's going to tell us false because it is not numeric. If we go ahead and say is character, it will tell us true because it's character. So we need to somehow get rid of those T's. Well, what do they mean? You could look it up, and if you do, you will find that T's mean just trace amounts. So basically it's 0. You could put in 0 or near 0 for this. So I know that I need to go ahead and fix an existing column, right? I need to take snow and I need to fix it. So if I'm operating on a column and I want to return the same column or a new column of a different name, I need to mutate, right? This is a data transportation, it's a mutation. And I'm operating on snow. And I know that I want to fix elements within that variable, right? So I know this is really renaming or regrouping in a sense. So this is a case for the case when function. And I want to say when snow is equal to T, then we say tilde, which means rename it to, and we have to pass in a character here because the column is already character. We have to say when it is T, go ahead and give it 0. That seems fair because it's trace amount. And if we want to do everything else, we say true. So everything else, rename it to itself. Right? And should have fixed those. Let's actually go ahead and see it with and without. So this is without the fix. Let's see if we can find one of those T's. There's one right there. At line 240, so let's keep that in mind. And here we'll go ahead and run it with the fixed variable that we fixed with case when. And let's go to line 240 and see if it's fixed. And indeed, it is fixed. It is a 0 now, right? But we still have a problem. And that problem becomes evident if we go ahead and run this. We see it's still a character. So we need to turn that variable and turn it into a numeric variable, right? So let's go ahead and do that. And I'm just going to go ahead and pipe right to the next line and say as.numeric. And now let's go ahead and view that and see what it looks like. Put an S there on accident somehow. Oh, I see how I broke it apart. There we go. And we can see now it's a double, which is what we want it to be. Now, what else do they want us to do? Convert the month variable to a factor to control plot ordering. So right now it's going to plot alphabetically. And it says the stringer package may be useful here. So I'm going to go ahead and load it. And we haven't dealt much with strings, so this is a chance to see a little bit of string operation. And we're working on the month variable, and we want it as a factor. So we can say month, and we will pass in factor levels of their month abbreviations, and there's happens to be a built-in constant in R called month ab. But the problem is they're in caps in our data set, and in that month.ab it is capital, it's title case essentially, right? So we need to turn our data into title case, and I'll show you what happens if we don't. So let's turn it into a factor. Factor, we'll say month, we'll say levels equals month ab, and we're going to get a sad response. Not quite the sad response I was looking for, because I piped forward two things. So let's go ahead and run that. But the sad response is all NAs. And the reason is, it says, hey, these are our levels, but there aren't actually any values by those levels. So there's nothing called capital J, lowercase a, lowercase n. It's capital J, capital A, capital N, right? So what we need to do is to turn month into title case. And there happens to be a nice function in Stringy called string to title. We can just go ahead and put that right in the pipeline, and you'll see what happens. Let's actually operate on this string so you can see what happens to it. And you see it capitalizes the first letter and lowers the rest. So let's go ahead and do that. And now it is a factor as we want it to be. It's perfect for doing data summarization. It's perfect for doing visualization now. The next step, it says assign the result to buffalo, snow, tall. That's pretty easy to do. That's just cut and paste and the assignment operator. Let's go ahead and run that code. And we now have an object named buffalo, snow, tall that we can use in our analysis. Now that we have that data set, it would be useful to understand the relationship between season and month. Are things changing over time? And we want to understand that in the context of months as well, right? So that's really a correlation between two categorical variables by another third continuous variable, and the continuous variable is snowfall, right? So the boilerplate for that is ggplot right here. Take the data, let's actually just grab that and use that. And the data in this case is buffalo, snow, tall. Let's go ahead and plug that in. And it wants the first categorical variable, which is season. It wants the second one, which is month. And it wants the numeric. We're going to fill by the numeric variable, right? And we're just going to pass on to the geom tile, right? Let's see what that looks like. Nope, we didn't pipe it forward, that's why. Let's go ahead and pipe it forward. Code always tells you when you're wrong. And we can see that, in a sense, maybe it would be better to flip season and month, right? So we can do some comparisons in other ways. I think ways that would be more useful. You gotta paste. If you're gonna cut and paste, you gotta cut and paste it in the right place. There we go. And now we can compare going down by seasons, or I guess up. And we can see the very bottom is 1940, the very top is 2017. And we're looking for changes within months. And it looks like there are some months that, it's kind of hard to really make any conclusions. It looks like things come in and out. One possibility is that December might be getting heavier snowfalls as you move up, but I suspect I'm doing the Texas sharpshooter fallacy here. So it looks to me like a lot of intermittent changes. You have some heavy years, some light years. So another way that we can look at the correlation between two categorical variables is with a bubble plot. It's almost identical in plotting to the heat plot, or heat map. So I'm just going to grab the same exact code, bring it down. Instead of fill equals snow, we want to do the bubble size. And instead of geom tile, we want geom point, right? And we can see, let's stretch it out a little bit. And we can see a similar type information that we could in the heat map. We can also do some things to make this a little more nice to look at. So we do things like alpha equals 0.6. We could scale the size. We can adjust that scale. So scale, size. And these are more advanced techniques, but I still want to show them. And we do range equals, and we're going to do -1, because if you set 0 for the size, it will, for the 0 months, it'll still plot a point. If you do a negative value, it will not plot a point. Let's go as high as, I don't know, let's try 6. And there you have some nice, nicer plot to look at just by changing a few things aesthetically. Now we'll be pushing along with tidying up data a little more with the breed name data set. So this is a data set that's fairly interesting. Let's go ahead and find out more about that data set. Use question mark, breed name. We can see it has a data set with 10 rows and 14 variables, has the breed as the first column, then it has names all the way down to the last column, which has the total number of that breed for the New York City Dogs data set, right? So kind of a cool real data set. And the first task it has us to do is to tidy the breed name data set. And so I'm going to grab breed name, bring it down, and assign it to an object called breed name tall. You can do that on your own. So I started out some boilerplate here for you, and why don't you pause the video and tidy up that data set on your own. Okay, let's walk through this a little bit together. I know right away that there's a problem I'm going to have to deal with. I am going to want to stack up all these names, right? And I'm going to want to call it the first column. I'm probably going to want to pipe it forward, and I'm going to want to say gather, and I'm going to call all the names of the name column, right? And then I'm going to want to call the counts, I'm going to call that n. But there's a problem. We already have a variable named n in the data set. And it's not necessarily useful in telling us what n is, and it really is the total for that breed. So I'm going to rename that variable, and we can do that with a rename function, and we're going to say total equals n, and n is what it used to be called, and total is what we want to now call it. Let's go ahead and see what happens when I do that. And you can see now the n column is called total. Now I can gather up the names, call them name, the cell values, I can stack them and call them n, and the last thing I need to tell is what columns to stack. So I could say a couple ways. I could do negative C breed and total. That will work. But I probably in this case would opt for the colon operator. I would probably say from Bella to Rocky. Those are the ones we want to tidy up. And you'll see we get the same result. All right, next it asks us to visualize the correlation between breeds and names. Please pause the video and do that correlation now with ggplot2. So we start out with the breed name, pipe it forward to ggplot2. We know that the X and Y are name and breed. We fill it by the number, and then we use geom tile on it, right? So let's go ahead and do that right now. And that's pretty intuitive, right? We could have also you might have decided to do it as a bubble plot, which means you do geom point, and we'd say n equals size. Maybe you would have grabbed from up here this as well. So just grab that, steal it, and bring it right down. We can go even a little larger on the size, I think. Go crazy. That's pretty interesting. And we can see that there are some correlations between breeds and names. So there it is as a heat map, and here it is again as a bubble plot. And one of the trends we notice is for Yorkshire Terrier and the Shih Tzu, it's fairly evenly distributed. So there might be a few more Bellas or a few more Cocos. But I start looking this over and I start realizing, well, we used N, so it's kind of not fair. It's hard to compare, across breeds. So we can compare within breeds. We can see Yorkshire Terrier within that breed. There's a few more Bellas and a few more Cocos and maybe a few more Maxes. We can also see within Boxer, for instance, there's a lot more Rockies comparatively, but you can't really compare across breeds because they're on different total amounts, right? So in the original data set, we had a total column, right, which we continue to bring over. So we kind of need a way to do this more fairly, right? So something that might be a little more fair is to go ahead and use proportions, right? So this is going to require a mutate, and we can say, well, n, let's do prop equals n divided by total, and we can use prop here instead. And now it's a bit fairer. We can compare up and down and side to side because everything's on equal footing. It's all in proportions now. So if you added up all of Beagle there, you would get a more fair comparison for across boxers. Okay, right? We can see some interesting things that now pop out even more so. For instance, Boxers tend to really be named Rocky disproportionately. German Shepherds tend to be named Max disproportionately. we can see that overall Rocky's not a real popular name. Well, it's fairly popular, but for boxers, indeed, it is much more popular. So pretty interesting. We could have done that as well for the heat map. And keep in mind, we could have flipped breed and name around. Let's go ahead and do that. Instead of geom point, we'll do geom tile. Instead of size, we'll do fill. And we can get rid of alpha. And we can do a little bit of changing of aesthetics here as well to make things prettier. So we could have done something like scale, fill, gradient, and you can pass in the gradient colors you want. So you can do low equals white, for instance, high equals red, and you can, we have an error there, I fixed it, and you get a little bit different look to the graph, right? Now I do want to talk about untidy data, because sometimes it is actually quite useful to have data that is not tidy, right? And it is possible to make data not tidy. So crosstabs are actually really quite useful. So let's say that we have a question: are some breeds where the breed has more than 500 more likely to be selectively male? So are there some breeds where we see more males in this particular geographic location? So we can take New York dogs, and we want to do a count of gender and the breed, right? So let's go ahead and do that. And you can see that we have a bunch of females, and then if you go further down, we would see a bunch of males, and we would have that particular breed, right? So right now it's kind of hard to do any sort of comparison. So what we need to do is, instead of it's already been gathered up, tidied, we want to spread gender out so we have males and females, right? And we're going to use a function called spread, and it is the opposite of gather. And what we want to say is take in gender, spread it across, and spread the ends into the cells. And now we can see across, we can see males and females, right? We can do nice little comparisons. And we want to do a total column, because one of the stipulations was we needed more than 500. So we're going to go ahead and do another column that has totals. So another column requires to mutate. We'll call it total. And that really is just is male and female. Yep, male plus female. And now we want to get rid of anything that has less than 500. So we can say filter greater than or equal to 500. And we need to tell it total is greater than that. So we have a condition there. And we're left with 36 different rows. So that's 36 different breeds, right? That's 36 that have more than 500. Okay. So you can see we're reducing our sample a bit. And now we want to find ones that are disproportionately male. So what is a way we can compare males to females? Well, we could go ahead and turn it into a proportion. And we could make another mutate statement here, or we could do it right inside of this mutate right here. And we can say, give me the percent. And to get percent, we'll need 100 times, we can just do male divided by total. We might as well call it something meaningful, percent male, right? And let's go ahead and round that so to 0 digits, right? Let's see what that looks like. And now we have percentages, but we want to know which are there some breeds that are more likely. So we're interested in the high percentages, right? So let's go ahead and arrange this by descending on percent male. Oops. And let's get a little bit more real estate. So we can see, wow, their bulldogs of both English and French type have 61% male. The next dog, which I can't pronounce its name, I don't even know what it is, has a high proportion of males, probably more than we would expect to see by chance. So perhaps people are getting males in higher rates for these types of dogs, or perhaps these dogs are, for some reason, genetically more likely to have males. But we would say for, 1,000 or even 688, we would expect this to be much closer to 50-50 if there was an equal chance of both males and females. So there are indeed some breeds that have more males than females. Might also be interesting, are there some breeds that people would prefer, maybe are preferring females in, or some breeds that are more likely to have females. And we can see the German Shepherd has a fairly low of 44, nothing compared to a 64, where we're 14% points above 50. This is 6% below 50. So perhaps this is a breed where it's more likely that this breed has females, or it's more likely people want female dogs of this particular breed. All right, we have some new tools for reshaping data. Go ahead and take the rest of this time to look at the Bob Ross data set. It is not tidy. Go ahead and explore it with exploratory data analysis. To do that, you'll likely need to tidy it up a bit. If you don't know anything about the Bob Ross data set, go ahead and type a question mark in front of it, and it'll tell you about what each of those variables are.